Rate of change. Definition. Let f be a differentiable function. The average change of f between x sub 1 and x sub 2 is the difference of the f's, which is delta f, over the difference of the x's, which is delta x, which also equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. This is the rise over run. This is the slope of the line between the points x sub 1, y sub 1, and x sub 2, y sub 2. Okay, it's this. It's the secant line. This is the run, and this is the rise. Definition. Let f be a differentiable function. The instantaneous change of the function at x equals a is the limit of delta f over delta x when delta x approaches 0. And if you recognize this, this is also the derivative of the function at x equals a. If this is a, then this point is with coordinates a and f of a, and here is the tangent line, and the slope of this tangent line at x equals a is the instantaneous change of the function at x equals a. Example. Find the average rate of change of the function f(x) equals x to the power of 2 minus 5x plus 3 on the interval 2, 8, and find the instantaneous rate of change at x equals 2. First, let's find the average rate of change on the interval 2, 8. We are going to use that, and we get f of 8 minus f of 2 over 8 minus 2, which is 27 minus 3 over 6, and we get 5. For the second one, we have to differentiate the function and substitute x equals 2. We substitute the function and we get 2x minus 5, and when we substitute 2, we get negative 1. Rectilinear motion. This is a motion of an object that moves along a straight line with position that given by the function st. The average velocity is the total distance traveled over the total time. The instantaneous velocity at time t is the derivative of st, we denoted by v of t, and the acceleration is at given by the derivative of the velocity at time t. I would like to show you an example of a rectilinear motion. Because the object is only moving on the straight line, it can only move left and right. To describe that, we have to write the time and the location. For example, here at t equals 0, it is at 5. t equals 2 is at 0. And then it moves to location 15. And it reached there when t equals 4. And then, for example, is moving that way. Let's do an example. Let's describe the motion where s of t equals 2t to the power of 3 minus 15t to the power of 2 plus 36t plus 2 in meters and t in seconds for t that is greater or equals to 0 less or equals to 4 seconds. In step 1, we will find the velocity vt and the acceleration at and their 0. v of t is the derivative of s of t, and we should write this as products of terms, and we get 6 times t minus 2 times t minus 3. It is 0 at t equals 2 and 3 seconds. I really care about the values for which the velocity is 0 between t equals 0 and 4 because I only care about describing the motion when t is greater or equals to 0 less or equals to 4. The acceleration is 6 times 2t minus 5, and it is 0 when t equals 2.5 seconds. Now we are going to do a chart. This is step 2. In the chart, we are going to evaluate the position st, the velocity vt, and the acceleration at for very specific values of t. For t equals 2 and 3 seconds, because the velocity is 0 when t equals 3 seconds. For 2.5 seconds, because the acceleration is 0 when t equals 2.5 seconds. And for the initial value of t equals 0 seconds and the terminal value of t equals 4 seconds. We have to fill in the chart in a very orderly manner, which means that the time has to go from the smallest one to the largest one. So we start with 0 and then 2 and then 2.5 and then 3 and then 4. I'm here evaluating this for you, okay? And I get that S of t is, to any given time, is as following. And then what is V of t? Again. And A of t. Now I will have to start analyzing that. What does it mean that the velocity is 36? It is positive. It means that the movement of the object is from left to right. When it's negative, it's from right to left. And then again, it's from left to right. What is the meaning of that? It means that the object accelerates. And what does this mean? That it accelerates. After I fill in the chart, I can do the motion chart. In the motion chart, first of all, I have to put down on a straight line, because I recall this is a rectilinear motion. The object is only moving left-right on a line. I'm going to put on the line all the important values of S of t, like 2, 30, 29.5, 29, and 34, and also I will put the 0 as a reference. Now I'm starting describing the motion. When t equals 0, the object is here. Then when t equals 2, is here. I have a little bit to erase the point. I cannot put it on the line because then I will not get a chart, just one line with circle on it. And this is the situation at t equals 2.5, then at 3 at 29, and then at 4 at 34. Now you can also check and see that indeed here, from left to right, then from right to left, then from left to right. And here's the motion chart. This is a complete motion chart. It describes everything, the location, the time. And if you also like, you can also write the acceleration near each one of these time slots. What is the total displacement? The terminal displacement is 34 and the initial is 2, so the difference is 32 meters. This is the total displacement. The average velocity of the first 4 seconds is the total displacement over the time, so it is 32 over 4, which is 8 meters per second. Now the more complicated question is to find the total distance traveled, but we are going to use the chart, so it's going to be pretty easy. From 2 to 30, we have 28 meters. And from 30 to 29, it's 1 meter. And from 29 to 34 is additional 5 meters. we can conclude that the total displacement is 28 plus 1 plus 5, which is 34 meters.